Hi, this is Mr. West, and today we're doing a Khan Academy tutorial on using inequalities to solve problems. This was a video requested by Hussein Shabazz, so thank you for requesting that. And if you want to request your own video, leave a comment and just tell me what you need. So we're going to go ahead and start with this. These are actually really relevant problems, and you're going to see that they offer solutions to real-world situations. Anand needs to hire a plumber. He's considering a plumber that charges an initial fee of $65 along with an hourly rate of $28. The plumber only charges for a whole number of hours, meaning it has to be like 1, 2, 3, 4, not like 5.5, something like that. Anand would like to spend no more than $250, and he wonders how many hours of work he can afford. Let H represent the whole number of hours that the plumber works. What inequality describes this scenario? Okay, so a couple things here. Initial fee, if we're looking at an initial fee here, we're thinking of, or at least I'm thinking of, y equals mx plus b. Okay, so that's slope-intercept form. And we know that this is the slope, m equals the slope, which is also known as the rate. And then the b is the y-intercept, which is also your starting amount. So when I see that we have an initial fee, I know that we're talking about the $65. An initial fee is not affected by how much you work. Okay, that would be the X, the number of hours. In this case, that is H. So instead, we need to have the 65 by itself not being multiplied by the number of hours. So I know A and B are both wrong because they have 65 times H. So now I'm down to C and D. C and D both also have 28 being multiplied by the hours because he charges $28 an hour. But now we need to decide if it's less than or equal to $250 or greater than or equal to $250. So this is his limit. That's his spending limit. He can't spend any more than that. So we have to spend less than that amount, and that symbol appropriately describes that. We wouldn't want that. We spend at least $250. We want to spend less than that. So C is our correct option here. So we're going to select C because we have the initial fee, we have $20 an hour, and we want to spend less than $250. Now, what is the largest whole number of hours that Anand can afford? So that's like the biggest part of this problem is we want to actually figure out how many hours we need to work. So we need to have the equation first. So let's go ahead and write that down. Okay, and I'm going to use a little lowercase h. I don't like the uppercase. 250, and I'm going to subtract 65 first. This is just this two-step equation. Okay, so if I see that we're trying to get h by itself, which we're trying to get h by itself, I need to isolate it by doing opposite operations until it is alone. So I need to do 250 minus 65. That's my first step, as I did. And what I do to one side, I have to do to both sides. So I get 185 is less than or equal to 28h. Now I'm going to divide by 28. I'm going to do the opposite of multiplying by h, because 28h really means 28 times h. So I do the opposite, and I get h is less than or equal to, what is that, 6.6. Okay, and now what you're thinking is like, whoa, he said he can only afford whole hours, right? Whole number of hours. So if he can't afford 7 would be too much, then the closest he can get is 6 hours. Okay, he'd be cut off at 6. He couldn't go to 7, so 6 is going to be our answer. And we're good. Let's move on to the next one. Okay, so I'm going to try to read through this quickly. We got paragraphs to read here. So Sophia's ordering sushi for a meeting. They changed plans and increase how many people will be at the meeting. So they need at least 100 pieces of sushi. Okay, so at least. That's a very important piece here that we're going to get to in a second. She had already ordered and paid for 24 pieces. The sushi comes in rolls, and each roll contains 12 pieces and costs $8. Okay. Let R represent the number of additional rolls that Sophia orders. Which inequality describes this scenario? So I'm going to start actually with the at least part. So if she needs at least 100, then what does that mean? Well, that means she could have 100. She could have 101, 102, 120. Okay, that's fine. Numbers she could not have. She can't have 90. That's too little. 99 can't have. Okay, so we need to think, okay, if we're looking about numbers that are at least 100, then we're looking at, which two options? we're looking at either this one or this one, because those numbers are greater than, our little expression over here on the left is bigger than 100, okay? We don't want less than 100 because we have to have at least 100. Otherwise, people are going to go hungry here, okay? So we know that C and A are both out. Now we just need to decide which one of these two. So we have 12 plus 24R or 24 plus 12R. Okay, so it says she had already ordered and paid for 24. Okay, so she already had that. What does that sound like to you? To me, that sounds like a starting amount. So I know C is my correct answer. Okay, and then we have 12R. It says here 12 pieces of sushi. Okay, so 12 pieces of sushi comes in rolls, and each roll contains 12. Okay, so basically R is the roll. So if you order like 2 rolls, that would be 24 pieces of sushi. So you multiply that. That's why 12 is being multiplied by R. It's like essentially your rate. So we know C is our correct answer. We're going to choose C. And what is the least number of additional money Sophia can spend to get the sushi they need? Now, this one looks like you just solve for R, but you don't. Okay, so let me show you what that looks like. Boy, I can see why you requested this video. This is very involved. Okay, so I'm going to go ahead and see what I can do here. 24 plus 12R less than or equal to 100. So I need to subtract 24 from both sides. And I get 76 is less than or equal to 12R. Ugh, we're going to get decimals here. That's no good. All right, but, okay, so I'm using a calculator. Let's see, so 76 divided by 12. Again, I was using opposite operations here. So we get divided by 12, and I get 6.3 repeating. Okay, so what is the least amount of money Sophia can spend to get the sushi they need? So technically what I need to do here is if I have 6.3 rolls I need extra, okay, really what I have to do is I need to get 7 rolls, right? You can't just get like 6 rolls, because if she needs at least 100, that means we'd have to get a 7th roll. I don't think you can order a roll and be like, hey, can I have only a third of this roll? So we really need to get 7. Now it says that each roll costs what? Each roll costs $8. So we just need to do this. If we need 7 rolls, okay, I think we established that we need at least 7 because 6 is not enough. We have to round it up to 7. And then each one costs $8. So we're going to have $56 she has to spend. That's a lot of money on sushi. So we get $56 and we'll check it. And we messed it up. Incorrect selected. Oh my gosh, I said not C. Why did I select that one? How do I can select that one. Okay, I'm not sure why I selected C. I think I got mixed up with I said it earlier, okay? I just wanted you to know that. I said it that early. It has to be greater than. Ignore that I got that one wrong on the thing, but everything else checked out. Okay. Carolina goes to a paintball field that charges an entrance fee of $18. Okay, so looking at this, they all have the same setup. Okay, I'm just trying to go quicker here. They all have that initial fee correct, so that doesn't help us. And 8 cents per ball. Okay, all those have that. The promotion says get $10 off if you spend $75 or more. Carolina wonders how many paintballs she needs to buy along with the entrance fee to get the promotion. Okay, so let B represent the number of paintballs that Carolina buys. Which inequality describes this scenario? Okay, so if you spend $75, so she needs to spend the $75. Okay, so it's not this. It's not going to be 10. That's way too little. Okay, it has to be the 75, and it's at least 75, right? $75 or more. Okay, so we're looking at the expression. It has to be more or equal to it. We're looking at option B. Let's make sure we actually select the correct one this time. All right. 2, what is the smallest number of paintballs that Carolina can buy along with the entrance fee to get the promotion? Okay, so I think we're just going to solve for B here. So we have 18 plus 0.08. I'm going to do lowercase b, greater than or equal to 75. Again, we're just solving these two-step inequalities. So I'm going to get my calculator out here for this decimal that we're going to have. So we have 75 minus 18 first. We get 57. Okay, and then we have 0.08b, and we're going to divide by that. Okay, so 57 divided by 0.08, and it's going to make it go up. Anytime you divide by a decimal less than 1, it's going to make it increase. So then we have b is greater than or equal to 712.5. Okay, so what's the smallest number of paintballs? Well, so if it's 712.5, we would need to round up, right? We have to go at least that, so we need more. So 713 paintballs is what she needs to get. That'd be weird to buy just 713. That's such a strange number. So anyway, but let's check it. There we go. Last one. Benjamin decides to treat himself to breakfast at his favorite restaurant. He orders the chocolate milk that costs $3.25. Then he wants to buy as many pancakes as he can, but he wants his bill to be at most $30 before tax. Okay, we can probably already pick out at least two. At most means we want to spend less than that. So we want this expression on the left to be less than 30. So A is a possibility and C is a possibility. B and D are both out because that one says greater than 30, and we don't want that. Okay, so let's take a look here. The restaurant sells pancakes in stacks of 4 pancakes for $5.50. All right, S number of stacks of pancakes that Benjamin buys. So $5.50. Oh, what were the two choices? So we wanted at less than 30, right? My thing gets all screwed up every time I do that. So A and C are my two choices because we want less than 30, and it costs $5.50 per stack. Okay, so we want C is our correct option because we have $3.25 starting price or starting amount that we've already paid for. $5.50 per stack. We want that to be less than $30. That's why I chose option C. What is the largest number of pancakes that Ben can afford? Now, this is tricky here. This Khan Academy is just testing you all sorts of ways. So it's asking for the number of pancakes, not the number of stacks. So be careful on that. Stacks is S. So once we do this and we solve for S, we need to calculate the number of pancakes, not the stacks. So the first thing I'm going to do is I'm going to subtract $3.25 from both sides. So we get $5.50. S is less than or equal to, what is that? That's 26.75, I think. Yeah. Okay. So now I need to divide by 5.5 to both sides. Okay. And then I need my calculator for this one. So I'm going to do 26.75. Whoops. Messed up. 26.75 divided by 5.5. Again, whatever I do to one side, I got to do both sides. So we get S is less than or equal to, that's an S, not a 5, S. And then I get 4.86 and so on. Okay, so that means I would need not 4.86 stacks. Okay, I would, if I got 5 stacks, that'd be too much, right? So I can at most get 4 stacks. Okay, because 5 stacks would cost too much. Okay, you have to understand that we have to be less than, so we need to round down. If it's greater than, then we would need to round up. And then it says how many pancakes? I think it says 4 pancakes in a stack, right? Stacks of 4 pancakes. Okay, so then we have 4 stacks times 4 pancakes per stack. And I think you guys see that we have 16 pancakes that he can afford. Dang, that's a lot of pancakes to eat. So there we go. Okay, so sorry I selected that one incorrectly, but I hope this was a helpful video. If you have any more questions on this, make sure to leave a comment. And if you want a video made for you, custom, go ahead and request in the comment section below. And I look forward to seeing you next time right here on Wes Explains Best.